Welcome to the Explainer. We've all wondered about it. It's been the stuff of science fiction for decades. What if an AI could build another AI? Well, it's not science fiction anymore. Today, we're talking about VibeTensor, a system that is literally rewriting the rules of technology as we know it. So let's just cut right to the chase. The biggest question of them all. Can an AI actually build another AI?
Well, the answer is a resounding yes, because it just happened. A brand new deep learning system called VibeTensor was just created, and it represents a massive, massive leap forward in what any of us thought was possible.
Okay, so here's our game plan for this explainer. First, we're going to get a handle on what VibeTensor actually is. Then, we'll look at the incredible process of how this automated engineering team of AIs put it all together. After that, we'll talk about our new role in all this, why this is such a monumental shift, and finally, we gotta take a realistic look at the risks.
All right, let's dive right in. What in the world is this system that has the entire tech world buzzing?
So, VibeTensor is a deep learning system. You can think of it like a super-powered toolbox for building AIs. But here's the crazy part. This toolbox was built almost entirely by other AIs. And listen, we're not talking about an AI suggesting a few lines of code here and there. We're talking about AI agents autonomously writing, testing, and perfecting an entire, complex system pretty much on their own. A good way to think about VibeTensor is like a high-performance car. Its engine is a ridiculously fast C++ core, giving it all that raw power. The steering wheel, that's the easy-to-use interfaces in languages like Python that we're all familiar with. But the most incredible part? The chassis. The entire framework of the car was built from scratch by AI. This is not just a new coat of paint, it's a fundamentally new kind of machine. And get this, the AI's work went deep. I mean, really deep. It didn't just build the shiny surface-level parts. It constructed the absolute heart of the system. We're talking about a custom data storage system, the complex code for managing powerful GPUs, and even the automatic differentiation engine, which is basically the mathematical soul of how an AI learns in the first place. So, okay, that's the what, but honestly, the how is where things get truly mind-bending. I mean, how does a team of AI agents actually build something this complex? The whole process is called agentic AI. This is a really key concept to grasp. I want you to forget about AI as just a passive tool. In this model, the AI becomes an agent. It's like an autonomous software engineer. You give it a goal, and then it just goes. It uses tools to search for information, write new code, compile it, and run tests all by itself. And here's how that AI engineer actually works. It's this continuous four-stage loop. First, a human sets the big picture goal, like make the system use less memory, and defines the non-negotiable rules. Second, an AI agent figures out a solution and applies the code change. Third, it automatically tests its own work to see if it broke anything. And fourth, and this is just wild, different AI agents review each other's code, acting like a quality control team to find bugs. So you see, it's not one AI working alone in a box. It's a collaborative, automated workflow that looks almost exactly like a super efficient human engineering team. It really just boils down to this simple cycle. Set a goal, write the code, run the tests, and review each other's work. All done by the AIs themselves. Okay, so if the AI is the engineering team, you're probably asking the same thing I was. Where do we fit in? Are human programmers out of a job? No, not at all. This isn't about replacement. It's about a brand new kind of partnership. The roles are just completely redefined. Humans, we become the architects. We provide the grand vision, we set the guardrails and the standards, and we step in to guide the really tricky problem solving. The AI agents are the builders. They handle the monumental task of writing, testing, and revising every single line of code. This is honestly the perfect way to think about it. We design the blueprint for the skyscraper. We decide what it should do, how it should function, what its purpose is. The AI then manages the entire construction project, from pouring the foundation all the way to inspecting its own work to make sure the building is solid. So let this really sink in, because this is the crucial part. Look at what humans don't do in this process. We don't write the code. We don't run the tests. We don't do those tedious line-by-line code reviews anymore. The AI has effectively taken over the nuts and bolts of technical implementation, and that frees us humans up to focus on strategy and the next big idea. Now, this change in roles, it's not just a minor tweak to the workflow. This is a profound leap that really redefines the entire nature of how we create software. Up until now, right, we've thought of AI as our co-pilot, something like GitHub Copilot. It sits next to you in the cockpit, it suggests the next line of code, it's super helpful for sure, but you're still the one flying the plane. VibeTensor introduces a totally new paradigm. The AI is no longer just the co-pilot. In a very real sense, it has become the lead system architect, fully capable of designing and building the entire project on its own, just based on our high-level instructions. The importance of the shift is just monumental. First, it proves that an AI can design a full-stack system, everything from what the user sees down to how the hardware is managed. Second, AI has made the jump from being a tool user to a tool maker. And this leads to the most staggering point of all, the potential for recursive self-improvement. Just think about that for a second. An AI that can improve the very software it uses to think. Each improvement makes it a better builder, which allows it to make even bigger improvements next time. It's a feedback loop that could just exponentially accelerate its own capabilities. Now, this all sounds incredibly exciting, and it is, but we need to keep a balanced perspective here. This is experimental stuff, and it comes with a whole new set of risks and challenges. One of the biggest risks is something researchers are calling the Frankenstein effect. This is where an AI builds a whole bunch of different parts that all work perfectly fine on their own. But when you stitch them all together, the final creation is, well, it's a clumsy, inefficient monster. Just because the parts work doesn't mean the whole thing will. And that's not all. There are other major hurdles, like hidden bugs that only show up after the system's been running for days. Plus, trying to maintain or secure code written by an AI can be a real headache if it's inconsistent or redundant. So the bottom line is, while VibeTensor is a massive breakthrough, it's not quite ready for prime time in critical real-world systems. Not yet. But let's bring it all back home. Despite the risks, VibeTensor is a true landmark achievement. It marks the moment that AI graduated from being just a user of our tools to becoming a builder of the fundamental infrastructure that it and we will run on in the future. And that leaves us with a pretty profound question to chew on. We've just witnessed the beginning of AI building its own foundation. So, when the builders can upgrade themselves, what comes next?